So chapter 4 is going to deal with functions, relations, and transformations. So for the most part, we're going to be dealing with graphs. It could be graphs of lines, could be graphs of radicals, could be graphs of polynomials. We're going to be looking at just about everything. Okay? So some vocab that we just need to remember, especially for this section, is our two types of variables, independent and dependent. Remember, dependent is the one that depends on the other. And if you remember, the dependent is always on the y-axis, and the independent is always on the x-axis. So you always look, which one depends on the other? Discrete and continuous, we haven't spent a ton talking about these. Discrete just means we really haven't connected the dots. It's a scatter plot. So it's discrete. So you see dots when you see the graph. Where continuous, you'll actually see lines. So it could be linear, it could be exponential, all kinds of different things. Anything that has lines is continuous. And then linear, nonlinear, well, linear just means it makes a straight line. And nonlinear means there's some type of curve in it. So like we said, it could be exponential, it could be a quadratic, it could be a radical, all kinds of things. Okay? So nonlinear, just not a line. So we're going to look at some graphs and make some interpretations of it. So for example here, it says, what is happening to the speed in each graph? Well, remember the speed is found by taking the distance divided by the time. So in this case, my speed starts off by increasing just a little bit, and then it keeps increasing quicker and quicker and quicker, right? So it starts off by increasing a little, but then it increases faster and faster. So we would say that the speed is increasing more and more quickly or rapidly. Something along those lines, more and more quickly. So you just kind of look at it, is it increasing or decreasing? And if it is, how is it increasing or decreasing? Is it increasing fast? Is it increasing slow? Something along those lines. So same thing here. Here's another one that's increasing, but if you look, it's increasing pretty fast right away, and then it slows down how much it's increasing. It's still increasing, but it's increasing at a slower rate. So we would say that this one is increasing like more and more slowly. Well, what if I was decreasing? What kind of line would decrease more and more slowly? Would that be something along the lines of this? Or would it be more so like this? Which one would be more and more slowly? Which one would decrease more and more slowly? Yeah, it would be the black one, right? The black one decreased fast right away, but then it levels out. So the black one decreases more and more slowly, where this red one decreases more and more rapidly, just like on that last one, but it's decreasing. Okay, so you just have to kind of look, see what's occurring. And then we're going to go the opposite route of this, and we're going to be given a situation, and I want you to make a graph. So your graph might not exactly match what we have in the answers, but it should be relatively close. So this one says the number of cars on the freeway and the time of day. So hopefully you've been on the freeway at different times during the day, so you can kind of get an understanding of this. But the biggest thing you just want to remember is what times are rush hour, and maybe like lunchtime as well. Those are some things to remember. Rush hour and lunch, maybe you have a few more cars during it. So first of all, we need to decide which one depends on the other. So did the number of cars on the freeway depend on the time of day, or does the time of day depend on the number of cars? Well, the cars depend on the time, right? So these depend, so that is our dependent, where the time of day is our independent. So I'm going to put number of cars on the y-axis, number of cars on the freeway, and on the x-axis we have the time of day. Well, in this thing, so number of cars, we could start at 0, and we could go up, count by, well, when it's like rush hour, if you're talking the freeway of the entire, like a metropolitan, for example, like Minneapolis, St. Paul, that's a lot of highways, of freeways. So we can maybe count by the thousands. So we could say like 1,000, 2,000, 3,000, 4,000, 5,000. So give some values that give an adequate scale. And the time of day, let's maybe start at, so I'm going to say this is 12 a.m. I got 2 a.m., 4, 6, 8, 10, 12. So there's noon, 12 p.m. And then we got 2, 4, 6, 8, 10, 12. So that would be starting back at the original. So let's kind of make a line here. So at midnight, do you think there's a lot of cars on the freeway? There's probably not a ton of cars. It's midnight, especially if it's not a weekend. Let's just consider just a weekday. We're talking, somewhere about like right here. I don't know. There's some hundreds of cars, but probably not 1,000 cars. So we'll start somewhere in the low hundreds. And then does it increase rapidly or kind of slowly, you would think? I would say it starts off kind of slow, and as it approaches 6 a.m., it would increase a little bit because people are starting to go to work, whereas from like 7 to 9, that's like one of the rush hours. So I would say I'm going to put rush right there. That would be a rush hour. Rush hour after work would be from like 4 to 6. Even like 3 is when school gets out. So a lot of those times are when a lot of cars will be coming. So let's just start working with this. So 12 a.m., it might even go down just a little bit, getting to 2 a.m., 3 a.m., and then pretty soon as we get closer and closer to work, it's going to increase a lot and stay steady for a little bit, right, until it gets just past rush hour, and then it might dip back down some, and then it gets closer to lunch, and it might come back up a little bit, and then it might come back down in the afternoon, and then it might go back up after school and rush hour after work, and then it'll slowly kind of decline until we get back to about midnight again. So something along those lines. I don't think there's going to be like sharp edges. It's going to be kind of gradual up and downs. But mainly I wanted to have some peaks around rush hour. It should speed up around rush hour. And I had another kind of slight peak around lunchtime. So your graph might look slightly different, but it should have peaks during rush hour, maybe a little bit of peak during lunch, and be really low like late at night, like midnight, 2 a.m. And lastly, let's get a graph and be given what's on each axis, what's the dependent, what's the independent, and let's make up a story. Okay, so I got time down here, so you could make it seconds, you could make it minutes, you could make it hours, whatever you want, and we could do height. It could be feet, it could be thousands of feet, whatever you need, depending on your story. So, something in general, you could say something like, about a plane. A plane took off, and, in a couple seconds, it went up about 500 feet. Well, let's be a little more specific. This is a straight line. So what would I describe? Would I describe that the height increased more rapidly? Did it increase more slowly? Did it increase at a constant rate? If it's a straight line, that means it is a constant rate. So I should say, if I'm going to describe a plane, I should say a plane took off and ascended at a constant rate for a few seconds. And then it flew at the same height. This is where that straight line is, right? The height didn't increase. It flew at the same height for about the same amount of time, for another couple seconds. And then it ascended again at a constant rate. So make sure if there's straight lines like that at an angle that you say something about it being a constant rate. That's important, okay? And if there's straight lines, it's kind of leveling off. So you got to describe that. Well, I'm going to get a little bit fancier. So I didn't go like a plain route. I thought that was kind of boring. So my route I went was a daring 7-year-old boy named Noah decided to try the steepest water slide at the water park. He started climbing the stairs at a constant rate. That's this piece right here. And stopped for a few seconds to look down. There's my next part. He stopped. He was looking down. He did this again 2 more times. Here we go. So climbed at a constant rate, stopped to look down, climbed at a constant rate, and stopped to look down, except what happened as he's looking down now, until he sat down at the top and started the slow, constant descent. See how I said constant descent? So slow, constant descent, because it's a straight line, to the steep drop-off of the slide. At what seemed like an eternity, even though it was barely 10 seconds, so I said this is about like 10 seconds, because these I said were like a couple seconds at a time. Noah slid down the steepest part of the slide at a super fast, boom, constant rate, all the way until he splashed in the pool with a big smile. So I added a little pizzazz in my story. Maybe you want to do the same, kind of spicing it up. Don't be so boring. But the biggest thing is make sure you have some key things about like constant rates, that they were stopping. Like here I went down slowly. This was fast. Okay, things like that. So you got to be specific at what the graph is drawn to. And that's about it.